Good afternoon. We as humans love to simplify things, sometimes too much, to three-letter words like AGI or ASI or MAGA, right? So what I would like to say is that we need to ask the question in a more nuanced way. That is, in what dimensions can AI help with regard to the progress of science? And the traditional way of looking at science was that it's in the shape of the letter T, where the vertical stem stands for doing depth-based research, and the horizontal line is for having breadth across various fields. And my view is that humans will continue to have the leading role in the STEM part, which is the depth of research, but in the horizontal STEM, that is where AI can really help, because it can bring many fields together. So we need to actually change the letter T to the letter pi, because you have multiple stems and a horizontal line connecting them. So for example, if you want to show that the lowest theta theorem, which is well known in graph theory, had a very close and subtle and unknown connection to what is called as contrastive learning in machine learning, then that could be something that AI could produce with the original ideas of graph theory or the original ideas of machine learning would still require a human element. And the reason that I'm still saying this is that if you look at the way that the best research has come, it often comes from people who are from outside the field. And that's because they don't have the tunnel vision or the baggage of having looked at a problem for a long time, which means that they come in with completely fresh thinking. They're not in a sense constrained by whatever they've learned in the past. And this is where you have the Achilles heel of AI. It is a victim of its success in the sense that it knows the past only too well. And often, in order to do the future, you need to forget the past. And humans are very good at amnesia, selective amnesia in many cases. And that is where I think that the humans will continue to have a leading role, because they have actually forgotten the past. And whereas if you look at machine learning techniques, they're built on looking at the past and understanding from that. It certainly serves a role for connecting disciplines or connecting ideas in computer science across fields or within the same field as well. Like, for example, I work in the area of database management systems. And the programming paradigm there is very different in the sense that unlike the normal procedural programming that you do, where you have a target and you basically write all the steps to reach the target, in database systems, you just specify the ends and let the system figure out the means to achieve it. And what we have shown recently is that there are many worldwide systems which are very popular, like DB2 from IBM or SQL Server from Microsoft and so on. All of them do good optimization, but if you use the LLM to connect them all up, then you find that you have much better optimization because it can take ideas from many different sources. So again, I would say that the humans give you the depth, AI gives you the breadth. And you should use the symbol pi instead of the letter T to describe research.
Thank you. Almost on time. Thank you. Amir, yeah.
Okay, so I'm probably
you had to put it closer to turn it on.
Okay.
Yeah.
I'm probably the least qualified computer scientist to talk about AI because my research is in logic and verification. I'm actually quite away from this topic. But the question that was quite interesting to me was whether there is a fundamental limit to what AI or generally machine learning algorithms can do. And of course, from the theory of computation, we have some answers to things that no algorithm can do. We know that there are problems that are undecidable. So definitely, the AI systems are not going to be solving those problems. But then I was thinking if there are any other limits, and I was thinking about the actual expectation that the general public has of the AI or machine learning systems. I was actually on X, on Twitter, and one of the things that I see very often is that there is a video or a photo, and people don't know if it's a deep fake or it's a real photo, and they ask Grok. And usually Grok just obliges them and gives them an answer, but the answer is not really correct. So I've seen examples where if you ask Grok in different languages, is this video fake, is it AI, or is it real, it would give you opposing answers. Now, I was thinking that actually, in some sense, this problem can be a good example of what can be a limit for what AI can do. Because if you think about it, there are two cases. Either at some point, we will have a machine learning algorithm that can detect these deep fakes, or we're never going to get it. If we never get it, then there is something that the AI systems cannot do, and that's detecting deep fakes. But if at some point we get an AI system that detects deep fakes perfectly, then that means that there are some features in real-world videos and some real-world images that the AIs cannot generate. So in that case, again, we found something that AI cannot do, generating that particular real-world photo or video. I just want to end with one observation. If you look at the pamphlet that was given to you with the photos of everyone who's taking part in this conference, you'll actually see that those photos are deep fakes. So all those photos have gone through LLMs, and interestingly, humans cannot really tell the difference. So when I was looking at those photos, all of them looked real to me except my own. And then I asked other people, and it seems that they can also tell the difference in photos that are of themselves or of close collaborators or family members, but not in general. So I would invite you to take a look at that pamphlet as well and see if you can tell the difference.
Thank you. It's interesting about this limit, complexity theory, what is computable or not. Maybe we can pick that up later. Please, Hesham. Yeah.
Okay. So we all agree that AI is very powerful. It has changed almost everything in our life now. It is a powerful co-pilot for scientists, but we need to differentiate between normal science and revolutionary science. So you mentioned Maxwell, you mentioned Einstein. So as Professor Omar Yagi just mentioned, AI can solve puzzles in the current paradigm, but it cannot think out of the box because it was trained inside the box. So it is a great co-scientist or co-pilot for scientists for working in the current paradigm, but for discovering new paradigms, new frameworks, AI will not work. And this is a problem. Why? Because the second point I want to mention is that I feel like we are putting all the eggs in one basket. So if you think about this summit, it is all about AI. If you think about the technical conferences nowadays, everybody is talking about AI. If you watch the news, AI is in the news. If you watch the stocks market, we have trillion-dollar companies based on AI. So if it turns out that we are not going to have AGI or ASI in the near future, if it turns out it is still far away, everything may just collapse. The stocks market will collapse. Many companies will go bankrupt. The scientists that were trained on using AI for almost everything will not have the capability to shift gears and look for the next out-of-the-box discovery. So this is a problem. We are putting all the eggs in one basket. So we need to think about this. The third point I want to mention is that when we talk about AI and AGI and compare it to the human being and the human brain, we forget that the human brain consumes just 20 watts of power. Okay, so the limitation now in AI, as many people talk about it, is in the electricity. You are melting our grades. Okay, so even if we reach AGI 10 or 20 or 50 years from now, how much power is it going to consume? The human brain, a miracle created by God subhanahu wa ta'ala, is consuming just 20 watts of power. So we also need to think about this. So that's all I have. It is powerful, it is scary, but we need to think about putting all the eggs in one basket. We need to think about creating new paradigms out of the box, and we need to think about comparing it to the human brain will be always unfair comparison because of the power consumption.
Thank you. Thank you. So we have about 24 minutes left, I think. We're supposed to open up to a discussion. Maybe we start with 5 plus 3, the 8 speakers. Let's start with that, and hopefully we can extend it. So maybe if I can take the chairman of this session prerogative, I can summarize a little bit what I heard. I can. I heard from Omar, this transformed your labs, right? Obviously, the AI has been an extremely powerful tool. It changed how you conduct your science and probably others. I heard from Hesham that you were a little bit, say, you could be a little skeptical, and then from Amir, you say, well, there's perhaps some fundamental limit, like computability and so on. So that's one issue that I hope somebody can address, in your field. Which group do you fall into? What's your extrapolation to the future. I think maybe that's a good one to start at. But anyway, the floor is open. You can also ask questions to the other speakers and so on. Yeah.
No, I just in a lighter vein wanted to add the point that AI can never succeed because it's too polite. Most good research comes from tough love. And I'm sure all the advisors here with your students, you have had situations where you actually essentially laid down the line to them. And that has actually worked out very well for them because they have changed their way of working or the way of thinking and so on. And that's required. But if you have something that is always polite, it encourages you to be lazy in a way.
You mean the current AI is too polite?
It's too polite.
Okay. So hallucination is polite. It's just wrong, but it's polite. Okay, good. Any? Please, one here. Yeah. yeah, that might should work, I hope.
Yes, thank you very much for this. I was just thinking about the degradation of AI, because if AI is using as input fake news, deep fakes, etc., how do you see the future with the degradation of the information that AI is based on, and how will this evolve? It will be not reliable after a certain time.
It's a matter of trust in discovering the truth, so to speak. Anybody, you want to? Yeah.
So if I may just add something to that, I'm not really worried about the degradation of AI itself, but I'm very much worried about the degradation of the internet as a whole. Because we are now in a situation where it seems like the vast majority of what you see on the internet is AI generated, and a lot of it is not really high quality content either. So would it get to a point where the internet is just unusable for humans because there's just so much AI slop? I don't really know.
Yes, Omar.
Yeah, I mean, I think that there is no doubt that the future challenge that humanity faces is that the search for the facts. What are the facts? I mean, this is what we do in science, and we're not going to change that when we're engaged with AI tools. We are still putting the human in the loop. We're still making databases that are, some of us, that are verifiable through experiments. So the experiment being interwoven with AI tools is absolutely necessary to making sure that we stick to the facts, which is exactly what we do as scientists. That will never change if we want to remain, if we want to sustain the science in the way that is supposed to be productive and useful to society. The other point about a lot of this doubt about the future of AI and all of this business about extrapolating into the future, I just want to caution that we don't extrapolate too much, because we're still learning what to do. We're still at the beginning of this revolution. We just need to make sure that the steps we take are not sloppy, that we're very careful about what we're doing, that it's verifiable. And I want to just remind everybody that science begins with doubt and questions. So this is very healthy. And, but we also, as scientists, we need to be optimistic. A doubt is good because it says why, and optimism is important because it says why not. We need these two things to work together. So I think that those are, some of the remarks that I want to give concerning some of the comments that have been sounded.
Maybe I can add something to follow up on. So I posed the question of, in the era of AI, how should we nurture our next generation? Let's say we're in universities, many of us are associated with. Obviously, it's not just transmission of knowledge, because you can get it so efficiently, right? And actually, in terms of the way you conduct your business, let's say science, it can really help a lot. I mean, Omar, you make a very good case of that. But I think, so in terms of nurturing scientists, it should be judgment, like what you're saying. How do you do the background due diligence? How do you gather the right data, talk to the right people to find out whether something is fake or true? I think maybe that's more important than actually learning how to code, okay, to me. Okay, so that's one view. I was just at a conference that talks about this. You know, so the conference called AI and Humanities. It was in Washington, D.C. So I can tell you the humanists, many of them are worried to death about that they will be completely replaced by AI. Because everybody will study AI, nobody will care about philosophy and ethics. But my view is that there's no better time no more important time for the humanities than now, because of what you ask. I think, but the expectation and the conduct of education got to match. Okay, we all got to adapt to it. That's my personal view. Any more? There's one hand, on the right there. Yeah.
Yeah, I wasn't on this panel, but I'm going to take my last opportunity as an actual AI expert. Omar Yagi's perspective is very much aligned with how we think in the AI field, the way we develop. We think of ourselves as developing not just tools that you can download and work with, but rather a thinking style and a problem-solving style that you integrate into your workflow, and then you expand your workflow, and then you verify and you test and all that. So the scientific method is very much alive in the kind of loop that he's talking about. Our goal is not AGI or ASI or whatever. That is hype. That's Silicon Valley nonsense. I'm kind of sad that it's even come up here. If you told me that we didn't reach some mystical goal of AGI in 10 years, it was at a disappointment, I'd say no. We helped the Omar Yagis of the world to discover wonderful things. He's in chemistry, but think about healthcare, think about transportation, think about all the things that actually affect human life. That's changing right now in a revolutionary way. So that's really the goal. The other point I want to return to is the point I made about economics. There's not many economists in the room. But when you think about science, you don't have to worry as much about people stealing, cheating, trying to game you. In the real world, people do that all the time, and it's not because they're unethical. It's because they try to get value for themselves, their country, their family, and so on. And so economists worry about that problem of how can I ensure that you're telling me the truth if I go into a market and you tell me something works? Well, there's reputational issues. There's things I can learn from watching the process around me. Markets have developed over thousands and thousands of years to support humans interacting with each other, even if they don't entirely trust each other. And if you don't have those kind of principles built as part and parcel of the AI enterprise, in addition to all the scientific checking and validation, the whole thing won't work. And that would be the disappointment to me, that thing just doesn't work. It leads to sacrifice, and it leads to systems working poorer than they should be expected to be. So it's a discipline that's going to take, like chemical engineering, electrical engineering, 20, 30 years to roll out and start to show its value. And we're at the very beginning, as Omar says. But I just want to say, this is not my opinion alone. This is kind of the people who've been developing this now for the last 20 or 30 years.
That's Michael, right? Michael, I can barely see you, right? Yeah. Well, it's really reassuring to hear your opinion about AGI and ASI from an expert like you. So
it really is a term it's for the Silicon Valley venture capitalists. It's to feed this hype bubble that something miraculous is going to happen. I think people in this room kind of know that's not how science and human life works.
So this reminds me of, I'm old enough to have experienced 2 AI winters. This hype has always happened.
Again, that's AI is not the term we've been using. We've been calling it machine learning. And there's never been a machine learning bubble. Good. It's just steady progress.
Yeah. But anyway, this hype has happened before. That's what I'm saying. Yeah. Anyway, so a hand way back there.
Yes. I want to make a comment about the comparison which has been made between AI and the human brain. The first one is, of course, that the human brain is much more efficient in terms of energy consumption, as has been noted. But I think there is another characteristic which is essential, is that the human brain is feeling emotions. Emotions means that it's not only an electronic machine, but it has connection with chemistry, with the fact that it is connected with hormones, with a lot of molecules which make it feeling the rewards of what it is doing. And I think discoveries are based on emotions. You are doing physics or chemistry or biology because you are curious to learn about the world. You have the ambition to contribute to knowledge. You have a feeling, a connection with the world which AI doesn't have. And I think this is also due to the fact that the human brain has been developed over billions of years of evolution, which has made it sensitive to things in the environment, which AI does not have, and I don't see that AI can have it in the future. At some point, it has been mentioned that Einstein discovered relativity through thought experiments. A thought experiment is something that you can do because you have an experience of the world and because you can see similarity between different kind of events, which comes from experience, from the fact that you are connected to the world, that you have intuition, that you have a kind of feeling about what's going on outside. And I don't see how the AI can have this kind of quality. So my belief is that AI is a tool, is a fantastic tool, but it is not something which will be our boss when we do physics in the future. At some point, you mentioned the fact that Nobel Prizes have been given to AI. In fact, it was not given to AI. It was given to the people who used AI. I can give you as an example the fact that there have been something like 25 or 30 Nobel Prizes which were given to people who worked with lasers, but it is not the laser who discovered things. It is the people who used the laser which did it. My feeling is that AI, it will be the same with AI.
So,
I hope so, because otherwise we're in a big trouble. If there is a kind of general intelligence, if we are going to a tipping point where AI will dominate the creativity and the imagination of human beings, it will be very, very sad, I think, for civilization.
so if I heard you correctly, your answer to the question posed in the theme, which is, can AI discover anything, right? That's what the theme is. It sounds like it's no from you. Is that correct? I don't want to paraphrase you.
I think it will help making discoveries as a very powerful tool, but you will always need to have behind that something which drives you, which is a need to know more things.
Okay.
And that's different.
Now, I know there are a lot of physicists sitting in the audience, Nobel laureates in physics. I asked a question about a thought experiment, which is if you had given somebody in 1905, but not Einstein, okay, the best LLM that they have, would we be able, as a human species, be able to discover all this stuff? That's the question. Sounds like your answer is no.
No.
I think that quantum mechanics could have been discovered by AI.
Aha, okay. And why
At least on the level of Bohr theory and so on. By enough observation, maybe not quantum mechanics, but the quantization would clearly be discovered by AI.
Okay. Yes, Brian, right? Brian? Yeah.
So with general relativity, I mean, one of the features of general relativity is that it was kind of came out of the blue. We had the precession of Mercury. That was the only evidence of it, really. And I can see David disagrees with me, so I'm going to let him go through and answer why he thinks I'm wrong. But to my mind, AI wouldn't have had an easy chance to train on anything to make sense. So the measurement of things afterwards, spurned by Einstein's ideas, that allowed us to kind of better understand the theory. And eventually, maybe it would have come out, but I think it would have certainly taken a lot longer than what we have seen.
Okay. Not everybody agree. That's good. Can be from the audience. I think we should, yeah, please. There's a hand. The person in a white suit. Yeah. Maybe you can say who you are and which organization.
Yes, I'm Professor Tangana from University of Free State, South Africa. I'm a mathematician, precisely fractional calculus. Just for people that may not know what is fractional calculus, you have what we call first derivative, second derivative. Then L'Hopital asks Leibniz, what if n is, for example, half? Then from there, we build what we call Liouville fractional derivative. And from there, we were able to build what we call Liouville fractional integral. And later on, there is a man called Capito that was working with a real-world problem. He came out with a new derivative. We call it Capito derivative. Now, as a student, when I was growing up, I noticed that we have two derivatives, but one integral. And I asked myself a question, how is it possible for us not to have an integral that is associated to Capito derivative? Because these two derivatives are different. I asked this question to many people working in fractional calculus. 65 years, nobody was able to answer the question. Then I discovered ChatGPT. And I asked the same question to ChatGPT. And ChatGPT told me that your question is very sensitive. And I convinced him to tell him that it is possible for us to have an integral that is associated to capital derivatives so that we should fulfill what we call in mathematics fundamental theorem of calculus. And that will help us to solve many problems. And with interaction between me and AI, I was able to introduce that integral. That actually, in our field, it is a breakthrough. Because the Riemann fractional integral that was introduced is using what we call continuous function, whereas the capital derivative is used what we call differential function. So people that think that AI cannot discover something, I think that AI can come out with an idea that can change our world.
Can you, okay, you finished?
Yes.
Okay, I was going to ask you to summarize your main point in one sentence. So,
yes. So my main point is that I think that AI can make breakthrough.
AI can what?
I think that AI can discover something.
Okay, all right, so that's the answer. Yes.
So I think that the approach that Professor Yagi is taking is more typical of the way in which advances have been made in science. It really is a combination of theory and experiment and sequential approaches to things, where AI can probably assist on both sides of that, both in experiment and in theory. But it will be the question of whether it can on its own, which seems to be the nature of your question, go out and discover something because it has read the literature. It may be able to do that in some instances, but by and large, its main effectiveness is probably integrating it into the scientific process.
That's a good point. So Omar, let me ask you, Omar. So you've experienced this enough. Have you at some point said, God, maybe they don't need me? Can you share your thought on that?
In fact, the students designed 7 agents that do what I do in the lab. You know, talk to them, advise them, criticize figures, ask them to reprogram the robot, and so on and so forth. I was very impressed. I mean, I was very, very impressed. I mean, it's not as good as I am, obviously, but not. but it's pretty good. It's pretty good, and I like it because it allows newcomers to chemistry, newcomers to my lab to plug in very quickly without having to find somebody and coordinate with someone, network with somebody. Here they can really start on their own. So to me, that is a power we hold in our labs to bring in more brilliant minds, which many of them are not really choosing science anymore. So I think that this is going to revolutionize our ability to recruit into the sciences, because AI allows us to at least come close to operating in our labs at the speed that society is operating. Okay, so that when students come into our lab, we don't have to send them back to the geologic age, right? Say geologic scale of everything is slow here, discovery is slow, and so on and so forth. So I think I am, as you can tell, I'm extremely positive about it. Of course, it's not, we are asking too much of AI at this point. We need to slow down and experiment with it thoughtfully so that it can get better and better and better. It's almost like raising a little child and teaching them how to walk or how to do things. Okay, they will get better and better with time.
I have one question to Professor Amir.
Yeah.
When are you going to have the AI interviewing your PhD students or your postdocs?
Yeah, yeah, good question.
So if you have 100 applicants and you don't have the time to check all these CVs.
Well, I think that's already being done.
Oh, wow.
Yeah.
Yeah, there was another question. Yeah, there's one here and there's one here. I think this hand was first when I saw that, and then you. Okay.
Omar, would you have found the first crystals of the class of compounds that you study with the help of AI. Isn't it so that what you are doing now is repetitive and based on your earlier work?
I mean, to me, I don't even like that question because it's not relevant. It's not relevant. We have a new tool, and this new tool is going to, first of all, it's unanswerable because it's not, I don't know the facts of that, right? But we have a new tool. We're at a different stage of development of science. So let's use it to further the questions that we are trying to answer at this age of the development of science. I think that's the way we should be thinking about it. I don't think the question of whether it would have predicted the moth that was cited by the Nobel Prize Committee. I don't think that's a really important question here. I think the important question is that here's a nascent tool, nascent concept. We need to nurture it. We need to work with it. We need to set the ecosystem for it. And more people need to plug in so that it can get better and better. And by the way, one last point I just want to make is that science in general has been highly centralized, where you're basically the G7 are the countries that have few scientists, few countries, few scientists solving the world's problems, right? And we need to make it more distributive. That's what I also learned from AI, is that if it doesn't scale, if it's not distributive, it's not going to be impactful. So I think that that's another aspect that's going to change this question about the university structure.
Let me let the gentleman.
I want to make one point. We talk about AI all the time. What is AI? AI is a whole bunch of tools, not just one single tool. And we make mistake by summarizing this and even personalizing it as if it was some kind of a being. We're talking about simulation, modeling, prediction, machine learning, generative AI. It's one big bag of different things. And some of the dissonance that is here is really created because we're confusing one thing with the other. So I just wanted to suggest to make distinctions. What are we talking about? What is AI? AI is not some kind of one thing, a person that something like an uber person, some kind of a god. It is a whole bunch of tools, and depending on which tool we are referring to, we might have different opinions and different judgments. That's the point that I wanted to make. Thank you.
Thank you. We have 1 second, but maybe I can summarize a little bit. First of all, personally, I really enjoyed this discussion. I think we have a wide spectrum of opinions. We touch on a lot of fundamental issues. There are skeptics. There are people who are really enthusiastic. There are people who think we're in the beginning of something fantastic. People who think that if we had not invented quantum mechanics, AI could invent it. Okay, that's very positive. But there could be some theoretical limit, just like computing has. Ultimately, AI is computing, right? Have we explored that? I don't know. I'm not up to date on the theory of computability for AI, so to speak. At least the current approach. By the way, I don't believe the current approach is the only approach. The big data plus the neural networks. There may be many, many other possibilities. But anyway, no doubt it's a tool that we can all use in a very efficient way. We should make sure our students and so on use them. We should educate them in the right way. And I think the future is bright. So with that, let me close this and I'll pass on. What's the next session? I think this session is over now. Okay, we should walk off the stage and someone will come back on? Okay, thank you. Thank you very much.